the sum and the difference formulas, you know? So the first thing you gotta do...
I'm just joking. Okay, we got 195. So if you're doing sine, cosine, and tangent, let's do sine of 195 degrees. That's the same as saying sine of 225 degrees minus 30 degrees. Right? That's what this says for number 9. Okay, so now you just need the formula. Yeah? Yeah. Okay, so the formula for sine with subtraction is going to be sine cosine. So we're going to go sine of 225 degrees, and then cosine of 30 degrees, and then minus sine. I like to do sine cosine like in the order like that and just switch the degrees. I like switching the degrees more. Sine cosine, and then I go 225. I think in the book they switch the trig functions and they keep the the angles in the same order. But anyways, so 225, sine of 225, if you guys check out the unit circle, that's going to be negative rad 2 over 2. And then you have cosine of 30 degrees, which is positive rad 3 over 2. That's a 3. And then we have sine of 30 degrees, which is positive 1/2. Cosine of 225, that's going to be also negative rad 2 over 2 because that's in the third quadrant, right? Right. Okay, so this is rad 6 over 4 minus plus rad 2 over 4. And so I get rad 6 plus rad 2 over 4, and that's my answer. Oh, snap, I forgot my negative. Good catch, good catch. That's because negative, positive. But this one's negative, so this one is positive, so I was right on that one. Good catch, Charles, good catch. Okay, let's do the rest. Let's do cosine. So it'll be cosine of 225 degrees minus 30 degrees. The formula for this one is cosine, cosine, sine, sine. So we're going to go cosine 225 degrees times cosine 30 degrees. And then, oh, dang, I'm running out of space there. Okay, is it plus or minus when we have a minus? Yeah, it's plus. You think opposite because cosine's a jerk. Okay, then we have sine of 225 degrees, and then times sine of 30 degrees. Okay, so this is rad 2 over 2, negative, and this one's going to be rad 3 over 2, positive, plus sine of 225, that'll be negative rad 2 over 2 again. And then we have sine of 30, which is 1/2. What do we get for all those? Let's see. This would be rad 6, negative. I didn't forget that time. And then we have minus rad 2 over 4. Okay, so let's write this out. Negative rad 6 minus rad 2 over 4. Or I can rewrite this as negative rad 6 plus rad 2. Both ways of writing it are correct. You'll probably see the second way written on a multiple choice exam. You should see this on a multiple choice exam. Just informed, the book has really, really funky looking answers. And so what they did was they, let's take this guy for example. They factored out something from the top and the bottom, I think. Or was, no, yeah, top and bottom. So I can take out something with the 4 on the bottom, so I don't have a fraction anymore. And then I can take a rad 2 out of the top. If I take a rad 2 out of rad 6, what is rad 6 divided by rad 2? Rad 3. Actually, one of them should be negative. Let's just make that one negative. Okay, what do I get when I go rad 2 divided by rad 2? Okay, so I think this is reversed in the back of the book, but this should give you a better idea. That is what you see in the back of the book. I like my answers better than this one. I think this one's excessive. I don't see the benefit of going that far, but they're both correct. Okay, should I do tangent really fast because tangent's nasty looking? Okay, so I gotta get more space for my tangent. Okay, here's our tangent. Tangent 225 degrees minus 30 degrees. Okay, now it says minus. I think it's is it tangent 225 degrees minus tangent 30 degrees, and on the bottom it's 1 plus. Okay, tangent 225 degrees times tangent of 30 degrees. Right? Right. Oh, man. Look at all that dirtiness. Okay, so now I have to think about 225. Oh, hey, 225. Isn't that just positive 1? I think it is. Cause, yeah, here, let me draw it for you guys who are a little slow with the unit circle. Let's see. We're going to go over to 225. I probably should have done this at the beginning, but oh well. If I draw my unit circle and I look at 225, which is right here, that's 225. My angle here is rad 2 over 2, rad 2 over 2 with negatives. Okay, now if I divide those, because that's what tangent is, it's y divided by x, I get positive 1. So I get 1 for that. And then what about tangent of 30 degrees? 30 degrees is over here. 30 degrees, that is rad 3 over 2 and 1/2. If I go 1/2 divided by rad 3 over 2, that's times the reciprocal. I get, that's going to be 1 over rad 3, which you guys lovingly know to be rad 3 over 3. Yeah, everybody good? Everybody good? So I'm going to put rad 3 over 3 for the second part. And then on the bottom, we have 1 plus, and then I have the same two tangent functions. So I'm just taking the top two numbers and multiplying them together. So you get rad 3 over 3. Oh, that's dirty. Okay, now I'm going to multiply the top by 3. Why? And the bottom by 3. Why? Because watch, it looks prettier. We have 3 minus rad 3 divided by 3 plus rad 3. Okay, now we currently have a radical on the denominator. We've done lots of stuff with this, and so I like this answer right now as it stands, but that's probably the calculus side of me. You probably won't find it in the back of the book, though. You know what you have to do next? Multiply the top and the bottom by 3 minus rad 3. I know. I don't know if this is in the back of the book, but this is what I would guess they would put. So it would be 9 minus 2 rad 3. And rad 3 times rad 3 would be rad 9. So that would be a 3. So I have to add 3 to that 9. And on the bottom, I'm going to get 3 minus 3. No, that's not right. It would be 9 minus 3. Okay, hold on. I got to finish. Finish my thought. Plus, minus, no. Negative 2 rad 3 over 6. Oh, dang. Now I could simplify that more. I could take a 2 at the top and the bottom and get 6 minus rad 3 over 3. And actually, that's my answer. But now I see that the book probably did something very annoying. They probably took out... Did they take out the 1/3? Like, did this? 6 minus rad 3? Yeah, they do that? That's probably what the book has. And I don't know if I mentioned, this is called the conjugate. I did it once, huh? Okay, so that's called the conjugate, and I did it to the bottom, the conjugate at the bottom, so I wouldn't have a screw down there anymore. So when I multiply a top, I go 3 times 3, which is 9, and I go 3 times negative rad 3, and then I'm going to go negative rad 3 times 3. Okay, so that's going to be negative rad 3, and there's going to be 2 of those, right? So I get negative 6 rad 3, because negative rad 3, or negative 3 rad 3 and negative 3 rad 3, that would be negative 6 rad 3. And then the last one, when I multiply negative times negative, it'll be positive, and then rad 3 times rad 3, that'd be rad 9, but rad 9 is just 3. So I have a positive 3 and a positive 9, so the top's going to simplify just a little bit more. I get 12 minus 6 rad 3. On the denominator, because these are conjugates, that's like you get a difference of squares. So you just have to square the first term and then square the second term and subtract them. So the first term squared is 9, the second term squared is 3, and so then I get 6. Looks like the top can be divided by the 6, like this can be divided by 6 and this can be divided by 6. So I take turns with the 6 and I divide both of those by the 6, and I get my final answer to be 2 minus 1 rad 3. And I don't have to write the 1. So that's your final answer.